All right, that's 12 o'clock. So welcome everyone. My name is Lora Rankin. I'm on the communications team at Cleveland Water Alliance, and I want to thank you all for taking the time to participate in our first webinar of 2022. Today, Water Innovation Postdoc Fellow, Dr. Jeff Pugh, will lead us in a conversation around getting started with affordable environmental sensor technology. And at the end of his presentation, we will be opening up a Q&A session. So please do feel free to post any questions using that Q&A function during the presentation today. And we'll try to answer as many as we can. We'd also love to get in touch after today's session to keep the conversation going. So with that said, I'm going to go ahead and turn it over to Jeff so we can get started.
Thank you, Laura. So thank you for joining this webinar. And before I start this webinar, I would like to ask 3 brief questions to the audience here, just to get you, just for me to know you a little bit better, to cater your needs here for the presentation. Okay, great. So it looks like a lot of you are from government and nonprofit. Great, thank you for sharing that. And then the second question we'd like to know about my audience here is which region okay, great. Looks like overwhelmingly we have a lot of Midwest folks here in the audience here. And then the last question, are you familiar with affordable environmental sensing technology here? Okay, so yeah, great. Looks like a majority of you are familiar with this technology, and I'm really glad that you are here. The main goal of this presentation is to help you learn about affordable environmental monitoring and sensor solution, and to hopefully motivate and get you excited about using these in your own use case, whatever that may be. So let's get right into that. So here is a graph that composed of different examples of the fundamental parts of an environmental monitoring system. It can range all the way from the sensors providing data in the field to all the way that data being transmitted and stored, and also in turn transferred to the end user, where the end user could be a variety, stakeholders, managers who utilize these environmental data and to monitor the environmental condition they are interested in. And obviously there are different parts connected and also involved in the system. If we wanted to talk about the entire system, we will be here all day. So for the purpose of this webinar, I will focus on mainly the part in sensors and telemetry. And these are the major components that are bringing the cost down for us to make these systems more affordable. So here is a very classic example of environmental monitoring. These are sensors that USGS and others has been utilized to measure water level throughout the US. And these are very classic research grade sensors that measure down to 1/3 of an inch distance accuracy. And at the same time, they cost fairly expensive money. So $4,000 for that one sensor to measure water level. So with that high price tag, it creates three major challenges. So first is it's really hard to kind of scale up and deploy a lot of these over large area. Oftentimes, if we wanted to monitor, say, an entire watershed, it's very difficult to deploy a lot of these over large area. And we often face the question, where is that perfect spot for us to monitor? The second challenge is because of the high price, it really creates barrier for everyone to be able to get access to these, especially for citizen science groups or the general public. It's really hard to purchase these, $4,000 sensors to measure water level. And then the third challenge is they are very costly for repairing. In the case if you break one of these, it will cost you a lot of money to replace them or repair them. So in order to solve these three different major challenges, there is the more affordable option that is out there available for us to use. And the main goal of affordable environmental and monitoring sensor solution is to drive the cost down by bringing in innovative approach. And I will talk about the different innovative technologies that are making this happen. So basically answering the question, how do we do that? So the first innovation I would like to mention is the introduction of the Lora Network. And before I talk about this, I would like to ask my audience here, what type of technology have you used, are you familiar with so far? Okay, great. So it looks like majority of you are familiar with manual download, and a lot of you are familiar with cellular and Wi-Fi. That's cellular and Wi-Fi, obviously, we are very familiar with them. Our computer and phones use them. LoRa is just another kind of network, just like cellular and Wi-Fi. It's different from them in the sense that there are these three distinct benefits of using LoRa. The first is it uses very low bandwidth. So it's very compatible for us to use this for environmental monitoring, simply because we don't need megabyte per second speed or gigabyte per second speed to upload water level data. So that's, in that sense, it's very compatible for us to use this. The second benefit of LoRa is it transmits very long range. So comparing to, for example, cellular network or Wi-Fi, it transmits much longer than those two options. And the third benefit is because it's transmitting such low bandwidth, it utilizes the least amount of power to upload data or communicate data. And that really gives us the ability to reimagine our environmental monitoring systems, because now we can be able to just use a very tiny 3-volt battery, and then we can be able to use these systems in the field and last for years to come, just with that tiny 3-volt battery, which is very extraordinary. The other reason innovation is on the sensor side of things. So here I'm showing you an example of measuring water level. Over the years, there has been a lot of innovations happening in this area, and sensor manufacturers has been working to make these sensors more compact and become much smaller. And in that sense, it drives the cost down for us to purchase these sensors. And I'm just showing you examples of water level monitoring in this webinar, but just bear in mind, there are also other examples of environmental monitoring, such as water quality monitoring or air quality monitoring. They are also seeing very similar trends as what I'm speaking here. So in this slide, on the right-hand side, we are seeing a whopping 30 times cost reduction for us to use that sensor for various the water level monitoring purpose. So obviously, it's very hard to not talk about money when we're talking about affordable approach here. So here I just construct a very rudimentary fundamental example here for one sensor. We are trying to monitor water level, and I computed all the costs you are seeing here. That's for 1 year, that first year you are spending to just measure water level. So in the classic approach, we choose a sensor from the research grade, and then we connect to very classic cellular network example, and then upload those data to a cloud data platform. For the affordable approach, we utilize a affordable sensor and then connect to, instead of cellular, we connect to a Lora network and then upload that data to the same data platform. So let's look at how much money we would save by combining and utilizing those two innovations that I have mentioned earlier. So on the sensor side, that's a whopping 90% savings for the first year. And then for the network, 98% reductions. And in total, we are looking at around $2,000 savings for that first year to just measure water level for one sensor. So this really opens up new opportunities for us to deploy more of these in the field, but also opens up opportunity for everyone to be able to access these, or more and more groups to access these for environmental monitoring. So one of the best way to learn is to learn through examples. So here I'm just trying to show you a example kit that we work in close collaboration with Limnotech here in Ann Arbor. And it utilizes these three major sensors, and they cost around $150. They measure these different parameters I'm showing you on the screen here. And just to give you a better sense what they look like, I actually happen to have them here. As you can see on the screen there, all of them transmits through this LoRaWAN transmission module. And this module communicates through LoRaWAN network, and they are made through Dragino. That's a company that makes them. And then you can connect various types of sensor to the transmission module to be able to monitor a variety of environmental parameters. So on the left, you see this is what I have here, a air temperature and relative humidity sensor. And then the water level sensor I have mentioned before, this is utilize the ultrasonic wave to measure water level. And for the temperature, water temperature, this is a very generic, temperature sensor that you can then submerge this in the water to measure water temperature. So obviously the sensor themselves cannot survive for a long time from the build itself. It would be more helpful to kind of fit these with casings and other parts. So we worked with Limnotech to develop these case using very accessible materials such as PVC pipe, as you can see in the middle here and to the right. These basically creates a protection around the sensor itself so that we can truly deploy them in the field and last for years to come. For the one on the left, you can see these ones use some radiation shield. I actually have one here. These are fairly big. just to give you a sense of the size here. And they are also very readily accessible for purchasing as well. So just showing you, just by adding an extra $100, we can be able to enhance these sensors and also be able to do affordable monitoring at the price. And the other great feature about the sensor kit is we were able to connect these sensor kits to a online data cloud data platform that's called Ubidots in this case. And we were able to build dashboards for these parameters where the data can be streamed live. So all these charts you are seeing on here for the dashboard, every time a new data point comes in, these charts refresh themselves. So it can have this real-time data streaming capabilities. So far we were able to deploy these cheap sensor kits around various locations within the Lake Erie region through partnerships, through various partners that we have here, through various projects as well. And before I dig into the specific sites that we have, I would like to ask my audience here, what is the most important environment that you think you will be installing your sensor? Okay. Great. Thank you for the answers. Looks like a majority of you are interested in installing these in lake and river environment. So these two are where we have already installed them, which I will emphasize more on these. So just by walking you through the different examples here to help you learn a little bit better. So in Ann Arbor, right here, we have been able to successfully install in kind of pond environments where we are able to install these sensors by, installing these metal stakes in the ground and then attach the sensors there to measure the variety of environmental parameters. There's a pond to the north of Ann Arbor. We were able to install the similar types of sensors where we tied 3 temperature sensors together and communicate through the same transmission module you've seen earlier and connect that into a smart buoy. And then that enables us to measure the temperature profile in the pond itself. And we're hoping these can help to measure for someday hypoxia, for example, using the temperature profile measurements. So at Wolverine Creek, this is a river slash estuary environment. And we were able to mount these water level sensors on bridge structures to be able to measure the creek water level throughout the whole network. And we were also able to do a comparison study. So comparing the classic sensors to the more affordable sensors, the quality between them, which I will get into later. And this is another one near City of Toledo, University of Toledo Lake Erie Center, where we were able to mount these to kind of like a lake shoreline environment where these sensors can be able to measure water level and water temperature right at the Lake Erie there. So these the picture on the right shows you the air temperature and humidity measurements there, which is nearby to the water level sensors. And this last example we have is at the Lake St. Clair Metro Park near Detroit, where we are able to partner with Wayne State University to install the $150 environmental sensor kit that we have. And in this park, we have a variety of different environments that we were able to install. On the left-hand side, this is the lake itself, so the Lake St. Clair. And then we were also able to install these in a kind of marsh environment at the park, as well as retention pond, where they have green infrastructures on site, so that we can be able to monitor the water level and water temperature in the retention pond. Additionally, we installed some of these the air sensor modules with to monitor the different microclimate that is located in the park itself, for us to do some spatial analysis of this temperature and humidity dynamics comparison. So at Overman Creek, as I mentioned before, we were able to compare different types of water level sensors there at the same location. And this is us trying to answer that very critical question. Even though we are spending less money to measure water level, how accurate is that affordable data, affordable sensor? And what is the quality of, the affordable sensor data? So this is just showing you a time series of the 4 different types of sensors that we deploy at the same location. And we utilize this NERS sensor as the reference to compare with the other 3 types. Here, I know there's a lot of things going on this graph. Apologies for that, but I just wanted to point out the water level sensor that we have utilized, the affordable version that's $60. That's in the green color, which is in this chart here. We basically compare with our reference data, and then we are seeing a accuracy offset of within 0.05 feet, which is quite a small amount of accuracy offset, I would say. And this really tells us the quality of these sensors isn't, you are paying less money. That doesn't necessarily means that you are recording data that it's, completely not good for anyone to use in that sense. So the other kind of recommendations I would like to give you is in terms of selecting the telemetry side of things. So here is the same slide I've shown you earlier, just trying to help you out in terms of making the right decision in terms of selecting the communication network. And I will be focused on the Lora network. So here just shows you on the right-hand side, there are a variety of different vendors out there that provide access to LoRaWAN network. They have their own different coverage difference, data control policies, and also pricing structures. Obviously, I would encourage you to look on their websites to find out more about these information before you make that right decision. And just to give you a rough sense, the pricing structure, they can vary between $1 per year per sensor to $10 per year per sensor. Some of these would require you to build your own network, and those are the three different examples that I have worked with so far. The other exciting development I wanted to especially mention here is through our own Cleveland Water Alliance initiative that we are currently working on to provide free LoRaWAN network access in the region that I'm showing you here. So within those coverages, there is actively development to provide free coverage of LoRaWAN, and the goal is to launch this in 2022. So stay tuned on that. In summary, I would like to mention, so with the affordable approach, we are now being able to spend less money to be able to conduct environmental monitoring. And with that, now it enables us to not only have more of these sensors out there to be able to measure spatial patterns across large areas, but also creates redundancies in the system, and also be able to give more access to more folks to be able to conduct environmental monitoring. And I would think that these two systems complement each other, so the affordable approach and classic approach, and we would need both for a variety of different purposes. And finally, the take-home message I would like to mention is that with the affordable approach, we can now be able to give more access to more folks to be able to conduct environmental monitoring. And in terms of for university and municipalities, it can enable those entities to create more spatial analysis, so deploying more of these to cover more area and retrieve these critical environmental data that previously could not be done. So just a quick mention here. After the webinar, we will be doing follow-ups to share the guide and the YouTube videos that I have created for the $150 sensor kit. These contains information on what you can do to put them together and also different materials that you would need. We would also like to launch a user community to showcase the experience that you have so far with these sensors, if you have already did, and also act as a platform for you to ask questions and help each other. Also, you can ask questions to me through that community as well for you how to use these sensors. We will also be sending out surveys as well to kind of get a sense of the interest out there to utilize these systems. And there will be a small teaser here. We are also working on sponsorship through the Cleveland Water Alliance to distribute 10 free kits. And that's more details for that will be upcoming. So with that, I would like to thank my generous funders, the Cleveland Water Alliance and NOAA CIGLR, for funding my research and my work. And special thanks to Ed Vahimi at Limnotech for critical support and help with making these affordable systems, and also the various project partners that we have for allowing us to install these systems and help us understand how these systems work in the field. So with that, I would like to conclude. My contact information is on there. Please feel free to contact me if you run into any questions setting up these sensors, or just simply wanted to learn more about them. I would be happy to chat. So with that, any questions?
Great, thank you so much, Jeff. We did get a few great questions through the Q&A. A few of them I think that were submitted earlier you did address, but we'll touch on those just to make sure that there's no further clarification needed. We did get one great question from Ed asking if there are any FCC permits required for the Lora Network that you're aware of.
I do not think there is. I can get more information on that part. I'm not quite familiar with that part right now. But.
Great. And then this one, I believe you touched on, but another attendee was wondering if the water level sensors are usable in streams.
Can you repeat that question again? Sorry.
Yes, if the water level sensors are usable in streams.
Yeah, so depends on what you want to measure. Let me just show the sensors themselves again. So it depends on what you want to measure. The temperature sensors, of course, they can be submerged on the water to measure water temperature. The water level sensors, they are more of indirect measurement of the water level. There's also water quality sensors as well. I didn't have time to mention them, but if you wanted to learn more about that, feel free to contact me directly for that.
Great, thanks. And Ed's jumped into our chat to clarify regarding the FCC question. There are no permits needed. It's license free for the Lora Network.
Thank you, Ed.
Great, just a couple more coming in here. I think that we've touched on everything that's been submitted so far. If anybody has any last questions today for Jeff, please do submit them either in that Q&A function. We've also got some people commenting in the chat. Thanks for all of your great notes there. Let's see, Hayden just popped in the chat. 2 things that often increase the cost of a sensor package significantly are a wiping mechanism for biofouling and wet mateable connectors and cabling. He's wondering if you can speak to how these components, the wipers and the cabling techniques, might be pacing the affordability, of these types of sensors.
From my work so far, I haven't worked extensively with water quality sensors. From my experience, these are as mentioned in the question, the wiping, these components are critical. And we are seeing a more affordable approach to water quality sensors out there. There are cheaper vendors out there to choose from. But I wouldn't want to answer that question without doing my own research about that. So I can definitely get back to you on that.
Great. And then Ronald's asked about batteries and how often they need to be changed for the sensors.
Yeah, so as I mentioned before, these transmission units, they have a 3-volt battery inside of them. They are like this big, and you can essentially connect to a sensor and then put these in the field for years. In our case, we have utilized them for 2 years or so before we have to change the battery out. But we are definitely using it at a very special case, because some of these sensors we have monitoring for, at a 5-minute interval, which is a lot of data. But if you tune down the monitoring interval, these sensors can easily last for 10 years or so in the field.
Thanks, Jeff. We have another question from Tom that I'm going to go ahead and tackle. Tom's asked where everyone can get more information about the updates to come in 2022 with the expansion of the network. And I would just advise everyone we have a lot of information at clevelandwateralliance.org. You can sign up to receive our newsletter. We're always sharing updates there, and also to follow us along on Twitter and LinkedIn, as we're constantly sharing updates on our programming there as well. Let's see, and then Russ says, small sensors with no solar panels look easy to sight. How long do you expect the batteries to last for the various sensors? And a couple people have asked how the sensors are doing over the winter.
That's a great question. So we have, so the first question, how long they will last. In our experience so far, they last for 2 years, as I mentioned earlier, or so, but we are logging at very high frequency. So it really depends on your own need, but I would say easily last for years. And then the second question, which is a great one, how long do they last in the winter? We have deployed them and put them to test in the winter, and they are performing fairly robust, and they are still functioning. For example, at Lake St. Clair Metro Park, they are still functioning there during the winter, and even through the freezing conditions as well. So I would say they are fairly reliable in the winter.
Another good observation from Jennifer, who's noted one of the biggest problems with water quality sensors is sensor drift and accuracy. And they're wondering if you have any data showing how accurate these are versus lab generated information.
That's another great question, which I didn't have time to cover, but for the water level sensor, what you're seeing here, we try to do a reference condition comparison. So this sensor, water level sensor, which is mounted nearby, that we have put a fixed plate so that this sensor is measuring at a fixed distance, comparing to the sensor that is in the pond measuring the water level that's always changing. And from our experience, the water level sensor is fairly, doesn't change much. There's no substantial, drift that we are seeing for the water level sensor. We're definitely working on testing out the quality of the water temperature sensors and see if there's any drifts there. But that's something that we will be working on for that.
Thank you. And we do have a bit of time left if there are any further questions anyone wants to pose in the chat or the Q&A. Give that a couple of minutes, and if not, I know Jeff did share his contact information. If you want to go back to that slide, Jeff, just so any folks who want to record your email can do so. And otherwise, we will be following up after this webinar with a link to this recording, as well as some details about that opportunity that Jeff mentioned to win a free sensor kit. So please do stay tuned for those. Look out for an email coming in from us. I'm just going to check one more time to see if we've got any last questions here today. Ed is asking about affordable water flow monitoring.
I haven't worked with water flow monitoring sensors for the affordable, using the affordable approach here. I believe Ed would have more knowledge in this area, but I think it definitely exists out there, and yeah, I can circle back on that answer.
Great. Sounds like lots of great opportunities to continue the conversation in the sensor using community. So looking forward to being in touch with you all and continuing that conversation. And once again, thank you very much for tuning in today. Stay safe, and we hope you have a great rest of your week.
Thank you.